So hello guys, today we are going to see this problem. Um, Best time to buy and sell stocks. So what happens here is that in this problem we have an array in which we are given the prices of stocks at a given day, and we can buy a stock at a particular day and sell at a later day, and we have to maximize the profit. For example, if we buy a stock at day 2, that is this is let's suppose day 1, day 2, and sell at day 3, the profit will be 4. If we buy at day 2 and sell at day 4, the profit will be 2. But if we buy at day 2 and sell at day 5, the profit will be 5. So that's how we are buying a stock at a particular day and selling it another day, and we are trying to calculate the profit. So there can be two approaches to it. First approach is the naive approach, in which we will fix our one pointer to the first element. We'll compare this element to all the other elements and see that if the next element is greater than this element, then we'll find the profit, and we'll do for all the elements. So we'll have a two for loops, and it will be O(n) square solution. So let's see that how we do it. So for integer I is equal to 0, I is smaller than prices dot size plus plus I, and we have similarly we have j equal to I, j smaller than prices and plus plus j. And then let's take a variable var which is equal to the current profit, which is equal to prices j minus prices I, and we have a profit which will be the output variable, so profit which will be equal to 0. So if profit is smaller than var, then in that case we'll update the profit is equal to var, and we'll return the output, return profit. So it passed the two test cases, but it will have a time limit exceed because we are running two for loops in it. Um, so the optimized solution for this will be the sliding window. So let me show you how we are going to approach this problem using the sliding window approach. Okay. So um, okay. So we have array something like this, and we have element 0 here, 1 here, 2 here, then we have 3 here, 4 and 5. So in sliding window, what we'll find is we'll find two things. One is the minimum element and other is the maximum difference. So minimum element uh, would be the minimum of all the elements in the array, and maximum difference is the difference of present element minus the minimum element. So what we'll do is we'll start with, so let's suppose this is I. We'll start with minimum element is equal to 0, and maximum difference is equal to, so rather I'll say minimum element is equal to int max, because whenever we want to take a minimum, we take it at int max, and max difference is 0. So at I equal to 0, we'll check that whether this present element is smaller than the minimum element. So yes, this is 7 is smaller than the minimum element. We'll take it as 7. And what we'll have is we'll check max difference is equal to element minus min element. So element is 7, min element is also 7, so max difference will remain 0. So at I equal to 1, we'll check whether the min element, that is min element is 7, element is smaller than min element. Yes. So this is element is smaller than min element. Right. So let me stretch it here. So yes, the present element is smaller than min element. We'll update it. It will become 1. The max difference is still 0. So in this case, we have our min here, I here, min and I both here. Okay. So now at I equal to 2, we see that min element, the present element is smaller than min element. No. So our I reaches here, and we have min element 1 only. And what's the max difference? Max difference is present element minus min element. So it will become 4, right? Because 5 minus 1 is 4. At I equal to 3, so see the window is sliding. Um, we have the element is 3, so we'll check whether this element is smaller than the min element. This is no. So min element stays the same at same position. And oh, sorry, right? And max difference, it'll check that whether the element minus min element is smaller than the max difference. So the max difference, this becomes 2, so the max difference stays 4. And I equal to 4. The min element 6 is not smaller than 1, so it will stay 1. And the max difference is element minus min element. So 6 minus 1 is greater than 4. So the max difference is 5. In this case, it slides here. And finally, at I equal to 5, I slides to 5. And the min element stays 1, and the max difference stays 5, because 4 minus 1 is 4, which is smaller than 5. So let's code this problem. So we'll have two things: min element, which will be equal to int max, and we have int max difference, which will be equal to 0. So we'll go through our all the elements. So I is smaller than prices dot size, and plus plus I. So in every iteration, we'll check that if present element, that is prices I, is smaller than the min element. So in that case, min element is equal to prices I. And we'll also check um, if the difference, that is if element, that is prices I minus min element becomes greater than max difference. So in that case, max difference is equal to prices I minus min element, right? And finally, we are going to return max difference. So max difference is our profit. So let's run it. Okay, it passes, and let's submit it. So it takes up the solution, so that's fine. So this is a sliding window approach. The time complexity for this algorithm is O1 because we are iterating the for loop once. The space complexity is O1 because we are not taking any extra array or something. So we are only taking two elements. For any input, we are taking only two elements out of it. And that's how we actually approach the sliding window problems. So thanks a lot. Have a good day. Bye.